This is for which paper?
Sorry, sir.
This is for which paper?
DIP, then statistical, yeah, statistical mechanics also, both of these.
Oh, 'Canvas file upload apparently has some issues, I guess. I don't know, today we used it for FY, but it wasn't that smooth. Let us see how it goes when we take our exam. Correct? So, how is TYBSc going on?
So it's all right so far. Um, Today both the lectures were online, so I don't think many people went to college. I'm not sure.
Yeah, yeah, we all were in the exam duties only.
Yeah.
I think Dubey sir was in the exam, and FY exams, a lot of people were there.
First 2 weeks are usually a bit light since there's not much workload.
Now practicals will start, but I doubt how will it go offline. I mean, I don't see a sense in keeping half the class at home and remaining half here. But this is the way things are right now. Plus all those issues of, you know, having a poor network, etc. Any which way, let's do at least some talking. Perhaps today I will be taking my last problems on Newton's laws. This was the problem we posed in the last class. Okay, so I think the one part we had solved, that what will happen if it is at V max, that if the speed increases, then it will the vehicle will, or the block will tend to slide upward spirally, spiral upward. So the friction will work down on the ramp. This is the ramp or incline. Friction will work down. In fact, this is what we had talked about. So if the friction works down, centripetal force this way, then the component of F and N will provide the centripetal force. So you have this set of formulae which will govern the situation. While you have another set of formulae when it will slow down. So if it slows down, then it will start spiraling downward like this. It will go down. If it's spiraling down, in that case friction will work in the upward direction. So that case we will look into now. So the normal reaction, the friction will now be working this way if it is V min. Remember, we are talking about in terms of velocity or T max. So friction will work upward. Normal reaction will work at 90 degrees. Mg will work vertically downward. I can split this into my components. What are the angles? You know that this is beta. So if this is beta, then this is going to be beta. This will be 90 minus beta. Therefore this angle is again beta. Then you can take components of n. Component of n in the upward direction is n cos beta. Component of n in this direction is n sin beta. So you get n cos beta, you get n sin beta. Similarly, you will now split your f. So this angle is beta, remember. So the component opposite this will be f. Let me zoom in a bit. This will be f sin beta, and the component of f this way is cos beta. So the upward two forces, n cos beta, f sin beta, horizontally downward mg, left side f cos beta, right side n sin beta. Remember, on the side, this side is your centripetal, mv square upon r is working. So now along x-axis and along y-axis I can write my equation sigma f x is n sin beta minus f cos beta. This is the sum total of all the forces, has to be equal to ma, which is mv square upon r. This side is positive, so this and this, these two are taken positive, this is negative. Similarly, sigma fy is f sin beta plus n cos beta minus mg is 0. There is no acceleration along x-axis, sorry, y-axis. So another relationship. Somebody is knocking the doors. Kevin, fine. Just to improve the spirits of the learning teaching mechanism, we must have a field trip, isn't it? What do you people think about it?
Yes, sir.
Yes, sir.
I mean, life has become so boring, correct? I mean, पहले तो
Absolutely.
we should organize a small little one day outing or field trip or something. You people should ask Jyoti madam about it. Ask her if a field trip is possible with TY. Because you people have missed college for so long. 1.5 years, more than 1.5 years now. And there won't be a time back, so you don't have any memories to carry on. Maybe a field trip. Okay. Of course, F is mu naught n, that's this remains. So you get 6 sets of equations. 1, 2, 3, 4, 5. 5 sets. 5 equations. Set of 5 equations. Remember, mv square upon r is mr omega square, which is m r omega square. Omega square is 4 pi square upon t square. This will be t max. Here you won't get a square. Correction. Okay. Now, it looks daunting task to solve so many, but many things are given. So sine beta, cos beta, all are given. Look at the situation. If you use, see, this is R. Okay. And this is H. We take this whole thing as R because dimensions of the block are not given. So we can assume that that block is much smaller than the cone. So now you are in a situation where you can judge this angle is beta. So what is sine beta? So hypotenuse is going to be, let me write it, r square plus h square. You get sine beta as side opposite, which is h upon root of r square plus h square, and you get cos beta as r upon root of r square plus h square. So you get sine beta and cos beta spelled out, and they are known. R is known, H is known. So you put here sine beta and cos beta. So you can first find out n. I'll just find out n and then leave it for you people to finish it. So f is mu naught n in this case, and sine beta is h upon r square plus h square. Plus n times cos beta, which is r upon root of r square plus h square minus mg is 0. Well, now I can take n common. So all you are left with is, you can see this is common denominator. So h square plus r square. Numerator n is common, so mu times h plus r is equal to mg. So n is equal to mg root of h square plus r square divided by mu h plus r. This gives you n. In the second case, once you get n, then you can put n here. F is mu times n, but n value from there, sine beta and cos beta, and equate it to this and get T max. So I suppose that's a very straightforward task. In fact, some algebra is there. So I hope you people can manage that. Okay. So rather we should look at some different kind of problem. So I have picked up one more. It's right on the screen here. 4.9 hammerhead is stopped from an initial downward velocity of 3.2 meter per second in a distance of 0.45 centimeter by nail in a pine board. In addition to this weight, there is a 15 Newton downward force on the hammerhead applied by the person using the hammer. Assume that the acceleration of the hammerhead is constant while it is in contact with the nail and moving downward. Draw the free body diagram for the hammerhead. Yeah, so the situation is very clear. There could be some wood log and to that you have a nail. Now to that a hammerhead comes and hits. This is your hammerhead. As a result, nail goes inside. Okay. So we can look at a situation which is halfway through. And going downward. How much it goes? It goes 0.45 centimeter. It is around 4 millimeter. And then stops. When it hits, the initial velocity was 3.2 meter per second. Draw a free body diagram for the hammerhead. So can you draw a free body diagram while it is in contact with the nail and moving inside? Try doing it, take 2 minutes. So we can draw a free body diagram. So I'll take hammer. What are the forces acting on the hammer? So this is hammer. Can anyone say what are the forces acting on the hammer?
The 15 Newton by the 15 Newton downward, and also 4.9 Newtons downwards due to its own weight.
Yeah, 4.9 Newton is the weight. So that is acting downward. And 15 Newton is working downward because it's applied force. Any other force that will work on it? Would there be any other force that will act on the hammer?
And the normal force when it is in contact with the nail,
Yeah.
which will be upwards.
When it is in contact with the nail, there will be a reaction of the normal force that will work in the upward direction. Good. What is the direction of acceleration of the hammer?
Upwards.
Upward or downward?
Since it's coming to a halt,
Yeah, true. See, speed is decreasing. So the acceleration has working upward. Remember, acceleration we show separately in the free body diagram. We don't show it in the line of the force. Just to emphasize that It is the effect of the force and not the cause. We have some visiting crows here. Okay, so that's good. In fact, so can we find acceleration by some method? So you can see initial velocity is 3.2 meter per second. So v0 is 3.2 meter per second, and final velocity is 0, and you travels a distance of 0.45 into 10 power minus 2 meter per second, meter. So can I find the velocity? I think we can, right? V square is equal to V0 square plus 2a into displacement y. So this will be 0 is equal to 3.2 square plus 2 into a into 0.45 into 10 power minus 2. Can somebody solve and give me the answer? Your acceleration will be equal to minus 3.2 square, 0.45 into 2 is 0.9. How much would this be?
I'm getting 1137.78.
1137.78.
Yeah.
1138. It's a huge, huge deceleration, right? Okay.
Yeah.
A huge deceleration. So now we can write, right? Plus n minus 4.9 minus 15 is equal to ma. A is mass of hammer. Mass of hammer will be 4.9 Newton. 4.9 divided by 9.8 into 1138. Why I am not using minus 1138? This is 1 by 2.
So because you've taken the upward direction as the positive, as
Yeah,
positive.
yeah. So do remember that sign conventions play an important role. This is not correct. 2 5 are 10, 1, 2, 6 are 12, 1, 2, 9, 8, 5, 69. So this has to be 588.9 Newton. You get a huge reaction force from the nail. Any which way, we did more. Identify the reaction force to each action force in the diagram. So there is one action reaction between the nail and the hammer. Since we are drawing the free body diagram for the hammer, we will looking only at this. This is the reaction force on the hammer by nail. How do you HN I will write. Nail, if you draw the free body diagram of the nail, then there will be a equal and opposite force working on the nail. Oh, this crow is making so much of noise. Let it be. Okay. Calculate the downward force exerted by the hammerhead on the nail while the hammerhead is in contact and is moving downward. So, what will be the answer to the B part?
So it would just be 15 plus 4.9.
It would be
19.9 Newton.
yeah. Downward force will be only this together. This is F down. Now, suppose the nail is in hard wood and the distance the hammerhead travels in coming to rest is only by 0.12 centimeter instead of 0.45 centimeter. The downward forces on the hammerhead are the same as in part B. So downward force is 19.9 Newton. Okay. What is then the force F exerted by the hammerhead on the nail while the hammerhead is in contact with the nail and moving downward? So reflects upon the C part. What happens to the acceleration in C part?
It will change. It will be some value greater than what it was, 4.45 centimeters.
Why will it be greater?
Because the distance it travels is smaller now.
Yeah, the y has reduced, correct? Y has become 0.12, which is like 1/4. So the acceleration will increase around 4 times. So the reaction force will increase by 4 times, correct? But what happens to the downward force acting on the nail? I think our reasoning have some issues here. Think about it. Force F exerted on the hammer is 19.9 Newton. Force exerted on the hammerhead in the downward direction is 19.9 Newton. But look at carefully what is being asked. Calculate the downward force exerted by the hammerhead on the nail. So what we are looking at is not the force on the hammerhead, but we are looking at the force on the nail. What will be force on the nail? So remember, the force on the nail would be the opposite of this normal reaction. Nail applies a force on the hammerhead, therefore an equal and opposite normal reaction on the nail by the hammerhead must act. Am I right?
Yes, sir.
So the answer to the B part would be this much force. What we have calculated is Hn. So the answer to this part is NH, which will be, you can say, minus 588.9 Newton. This is going to act downward on the nail. So Newton's second law, remember the lesson that we learn from here or we revise from here is Newton's second law demands us for the segregation of the body on which the force is working. So you have to be very clear in your mind that which is the body on which the force is being calculated. So here we are calculating the force. The forces are given on the hammer but asked on the nail, not on the hammer. On the nail by the hammer. Suppose for the academic sake we draw the free body diagram of the nail. How does it look like? What are the forces acting on the nail? Of course, its weight will act downward. What else?
And the force whose magnitude is equal to N in the downward direction.
Yeah, the force by the hammer on the nail. N, normal force on the nail by the hammer. That will be in the downward direction. Any other force that will work on it? On the nail?
No.
You don't think so?
No.
What about the wood log?
Oh, okay. So the normal force.
There has to be a normal force on the nail from the wood log, correct?
Yeah.
So this is how the free body diagram. Acceleration is, what is the direction of acceleration of the nail?
That will be downwards because the hammer is pushing it into the.
That's right. But are you sure it will be downward while acceleration of the hammer is upward? Think about it.
No. This will also be upward because
See, the
eventually it has to.
hammer and the nail are always in contact, right? That has been assumed. That एक बार ये टच किया तो ये कांटेक्ट में ही रहेंगे, कांटेक्ट लूज नहीं होगा, right? So if hammer is slowing down, obviously nail is also slowing down. मतलब जब आपने हिट किया था उस समय नेल की भी स्पीड सबसे ज़्यादा थी, which goes on reducing. So there is a acceleration in the upward direction. Yeah, so that's how the free body diagram. So problem is asking you only this component कि ये कितना है, that is force exerted by the hammer on the nail. This is same as this one because they are action reaction pair, and that can be calculated. If the wood is a hard wood, then this distance will reduce, therefore acceleration will increase. As the acceleration increases, your normal reaction will also increase. You will get a larger number. Okay, so fair enough. I think these were interesting questions. We continue to do this kind of questions. Let me just stop the streaming part and then we can do some talking.